What type of element is represented by this combination of subatomic particles? O, H, F, or Fe. The subatomic particles are protons, electrons, and neutrons, all of which have a certain mass and charge. So we have 9 protons, 8 neutrons, and 7 electrons. But how does that help us discover the elements of interest? Well, let's first identify these elements. We've got hydrogen, oxygen, fluorine, and iron. And you may have noticed that there's a number in the corner of each elemental box. This is called the atomic number, and it's unique and distinguishing for each element. The great news is that atomic number is the exact same thing as proton number. So if iron, for example, has an atomic number of 26, it therefore has 26 protons. That means that because our substance of interest has 9 protons, it must be an element of fluorine. However, we're not done because we're not just going to ignore neutrons and electrons. Let's specify the charge of this fluorine given its combination of subatomic particles, 9, 8, and 7. Is it -1, +1, +2, or 0? Now the subatomic particles are distinguished by their mass and charge. We're talking about charge here, and a proton has a +1 charge, an electron has a -1 charge, and a neutron is neutral. Because of that, when we calculate the charge of an element composed of these subatomic particles, it's going to be protons minus electrons. We ignore neutrons because they don't contribute any charge. So for our fluorine element of interest, since we have 9 protons and 7 electrons, the charge overall is going to be 9 minus 7, therefore +2 overall, making D our final answer, F2+. But wait! We are not done. We still haven't addressed the fact that there are 8 neutrons in this particular isotope of fluorine. So how would we illustrate then in a final full isotopic diagram? Well, I'll tell you right off the bat that the number in the top left corner is not equal to the number of neutrons. So we'll cross this out as the potential isotope of interest. Instead, this orange number is the mass of the isotope. We covered earlier that the subatomic particles each have a certain mass and charge, and in this case we need to acknowledge the fact that both protons and neutrons each have 1 atomic mass unit, and an electron's mass is treated as 0 because it's so small. Because of that, when we calculate the mass of an element composed of these subatomic particles, it's going to be protons plus neutrons. We ignore electrons because they don't contribute any significant mass. So if we have 9 protons and 8 neutrons for this isotope, the mass would be 9 plus 8. Therefore, the mass of this fluorine isotope would be 17 atomic mass units, making B our final answer, and you may have noticed that it just says 17 rather than 17 AMUs. To ensure you understand the ins and outs of correctly writing and dissecting isotopes, be sure to check out the video on your screen and in the description.